Hello, my name is Waramizu and my number matrix is 01DPU20F2002. Today I will introduce you about what is counterflow heat exchanger. A counterflow heat exchanger is one in which the direction of the flow of one of the working fluids is opposite to the direction to the flow of the other fluid. It just takes one stream and reverse. That means the hot fluid enters from right and it cools against the already warm up cool fluid from the left.
Next, advantage of counterflow heat exchanger. Number one, uh, the advantage is it take a low cost. Number two, easy maintenance. Number three, higher thermal efficiency used in gas to air heat transfer. After that, disadvantage of counterflow heat exchanger. Number one, the disadvantage is limitation in terms of phase change application. Second disadvantage is typically medium to high pressure drop. And lastly, relatively small tolerance to falling and chemical aggressive fluids. Next is the different parallel and counterflow heat exchanger. Parallel and counterflow heat exchangers are different in the flow, direction and the heat transfer diagrams. In parallel exchangers, both of the inlets are placed on the same side, and we have all the outlets on the other side. The maximum temperature difference is happening in the inlet, and it decreases to reach minimum at the outlets. It is totally the inverse type compared to the counterflow. Inlet and outlet position and temperature diagram for the parallel and counterflow heat exchanger is presented in the figure. The base of all heat exchanger is simple, and it is the transfer of heat from the hot fluid to the cooler ones and exchange energy between them.
Assalamualaikum warahmatullahi wabarakatuh and good morning to madam. My name is Muhammad Izzi bin Abdul Razak and my matrix number is 01 DPU 20F2027. I'm here today to share with you all about some related question that I found from the internet that I have been solved the question. First of all, let me read the question to you guys. A counterflow double part heat exchanger is to heat water from 20 degrees Celsius to 80 degrees Celsius at a rate of 1.2 kg per second. The heating is to accomplished by geothermal water available at 160 degrees at a mass flow rate of 2 kg per second. The inner tube is thin walled and has a diameter of 1.5 cm. If the overall heat transfer coefficient of the heat exchanger is 640. The question is, determine the length of the heat exchanger required to achieve the desired heating. Okay, let's move to the solution. Before we go through to the math problem, we need to have a few assumptions with the question. Like first, based on the question, we need to assume that steady operating condition exists. Then the heat exchanger is well insulated so that heat loss to the surrounding is negligible. Then change in the kinetic and potential energy of fluid streams are negligible. Last, we need to know about there is no fouling, I think. And one more, the fluid properties are constant. Okay, we move to the next step is we need to know the properties that we have, just like the specific heats of water is 4.18 kilojoule over kilogram. Okay, and the specific heats of geothermal fluid is 4.31. Okay, we go to the step 3, I think. So on this step is we need to calculate the Q dot, which is we have right here the formula is Q dot is equal to M dot times with specific capacity times with the temperature out minus with the temperature in. This formula is related to the water. Then we insert the point that they have give us, which is m dot is equal to 1.2 times with 4.18, which is specific capacity for water, and times with delta T, which is 80 minus 20. So after we times with the all of them, we get 301 kilowatt. The formula is same, which is Q dot is equal to M dot times with specific capacity times with delta T. But in the delta T, we need to minus the temperature in to the temperature out. This is not same to the Q dot for water, which is temperature out is minus with the temperature in. Okay, in this formula, we need to resolve again the formula because we need to find out the temperature out for geothermal fluid. So after we resolve it, we get that temperature out is equal to temperature in minus with Q dot over M dot times with specific capacity. After we resolve the equation, the formula, we insert the point or the answer that we get, which is temperature in is equal to 160 minus with Q dot is 301 kilowatt that we get over with M dot, which is 2, and times with the specific capacity of geothermal, which is 3.81. After we calculate it with the calculator, we get the temperature out is 125 degrees Celsius. And then after we get the temperature out, we need to calculate the delta T1, which is the formula is TH in minus with TC out. For delta T1, the TH in is equal to 160 minus with the TC out, which is 80. After we minus it, we get 80 degrees Celsius. Then for the delta T2, the formula is TH out minus with TC in, which is our TH out is 125 minus with TC in, which is 20. 125 minus with 20, we get 105 degrees Celsius. After we find the delta T1 and delta T2, we should to calculate the LMTD like the question request. So the formula for LMTD is equal to delta T1 minus with delta T2 over ln delta T1 over delta T2. So we put our answer that we calculate. It should go like 80 minus with 105, which is delta T1 minus delta T2 over ln 80 over 105, which is 80 is our delta T1 over 105 is our delta T2. So the answer that should be is equal to 92 degrees Celsius. Okay, the next step is we find the surface area for the heat exchanger, which is written by AS. The formula is AS equal to Q dot over overall of the LMTD. So we put our point, which is Q dot is equal to 301 kilowatt over 640 times by 92, and we get 5.11 meter square. This is the area of the surface area for heat exchanger. Okay, next we need to find the L, because the formula of surface area is AS equal to pi dl. So we need to find the L. So we resolve the equation like L equal to surface area over pi d. We put our point, which is 5.11 over pi times with 0.015, which is d, and we get the final answer is 108 meter.
In conclusion, heat exchangers are pieces of equipment used to transfer heat from a hot fluid to a cool fluid. They are essential as they carry out the task of changing the temperature of the more valuable fluid that is used later on in this process. The fluid may be of different phase, which may be transferred into another phase. They may be separated by a conductive wall or have direct contact. Heat exchanger operate using the same set of thermodynamic principles. thermal energy is always conserved in heat exchanger. The direction of heat flow is always from the fluid with higher temperature to lower temperature. Thank you.